take your attention just for a second up front. I have put the review tutorial up there for the test that we did on Monday, so if you want to go back and look at that. I also put the pre-lab instructions up there. It goes through some of the equations if you missed that. I've also put these 2 review sheets that you picked up last time up there, so if you want to see if you can remember stuff and try and do it again, you can print it off. You can do whatever you need to for that. So as far as that goes, they're up there. Next time is a test. Tonight after school is the review for those that want to come. I would like to go over, though, anything that you would like to go over right now before I set you free. If there's something on the lab, or if there's something you're not understanding in your homework, or if there's whatever that you'd like to go over as a group. Anything? Yes?
So, like, knowing what to do for, like, the whole map, like, for different problems, you do, like, different things, but I just, like, kind of get confused on, like, what, like, based off what it's asking, what I should do.
Okay, so the big thing with the mole map, first thing you want to do is figure out where you're at, and that will tell you what you need to do. So when you're in, so for instance, if I start with atoms and I'm trying to get to moles, then I'm only going to have one conversion. If I start with grams and I'm trying to get all the way to atoms, I'm going to have 2 conversions. So the first thing is to identify where you are, and where you need to get. The only time you have to add up the formula weight is when you go back and forth between moles. Okay, so from going from grams to moles, you would divide by the formula weight. To go from moles to grams, you would times by the formula weight. On this one over here, you're going to use Avogadro's number, which is the 6.022 times 10 to the 23rd. Okay, to go from moles to atoms or molecules, you times. To go from atoms or molecules to moles, you divide. The only other thing that you need to know is if you have a compound, say that I have CaCl2, and it asks for how many atoms of chlorine. Once I find molecules of chlorine, then I'm going to have to do it over here. So once I find molecules of chlorine, calcium chloride, I'm going to have to then say in 1 molecule of calcium chloride, there are 2 atoms of chlorine. So that was something that we really hadn't talked a lot about, but that would be the end thing if I have molecules and I have to go to atoms. Okay, atoms are usually just an element. Okay. Anything else that you'd like to go over?
Have you already done the Sanford? Is that one?
Nope, I haven't done that one yet. I haven't gone over that. We went over the other one a little bit.
Are you able to classify equations according to their type?
So according to their type, there it is over here. So if you have 2 or more things going to one thing, that is synthesis.
Oh, okay, so it's just that. Okay.
Yeah.
I just didn't exactly.
Or combination. Yeah, so there's the 5 types. There's synthesis, boy meets girl, and they become a couple. Decomposition, where they fall apart. Single displacement couple and somebody, and that makes a new couple and somebody else is kicked out. Yeah. And then there's double displacement, which I called the dance disaster, where they switched partners and went home. And then there's combustion. On combustion, you're always going to have oxygen on the reactant side, carbon dioxide, and water on the product side.
That's the CHO ones, though, right?
Right, the CHO.
And then when you're balancing equations, you always do H and O last, right?
Right.
And then do you do, like, if you have, like, a bunch of other ones and CHO, do you usually do C and then H and O?
Nope.
Or does C not matter?
C doesn't matter. I always just leave hydrogen and oxygen till last to balance.
So those gotta be last.
The Santa says ho 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 at the end of the year. That's how I remember it. Okay? Except if you watch Christmas Chronicles on Netflix, I don't do the ho 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 thing.
What does he do?
Nothing. He's cool.
Why is it chill Santa?
Yeah, he's chill Santa. If you haven't seen that, that's pretty awesome. I like the Jailhouse Rock scene.
Would you recommend that?
Yeah, definitely.
Will watch.
It's a good one to watch. It's a totally different look at it.
I have not watched that yet. I will have to.
You'll have to. It's a pretty good one. It is not normal Santa. I do like his beard, though. His beard's pretty awesome. Okay, off of that subject, back to chemistry. Is there anything else you'd like to go over as a group? I know in your homework, and this is some that some kids were asking me last period, it had something like, I don't think this is exactly right, but we'll just pretend like it is, going to 2NaCl, and there was a 2 here. And you had to determine which was oxidized, which was reduced. Okay? So remember that any element by itself has a 0 charge, but when it goes to a compound, they gain their own charges. So sodium is in the first column, it will be a +1. Chlorine's in the second to last column, so it'll be a -1. So as I look at this, sodium is becoming more positive, so it's Leo, which means it's oxidized. Its loss of electrons is oxidation. And chlorine is Gur, gain of electrons is reduction. Okay, remember that they're opposite though. So if it's being reduced, it's the oxidizing agent. If it's being oxidized, it's the reducing agent. Okay, and then it has you write the formulas for each, for the oxidation and for the reduction. So the oxidation would be Na, 2 Nas, going to 2 Na pluses plus 2 electrons. And the chlorine would be adding to those 2 electrons to make 2 Cl minuses. And these, of course, would be AQ, but I don't think they have you put the AQs on. So remember, in order to be a positive or negative, we're moving electrons around. So oxidized means I've lost electrons. So this was the Leo, losing electrons, and this is the Gur. So one has to lose 2 electrons so the other one can gain the 2 electrons. Because if we add that up, in your homework you do, yes, in the homework. I haven't seen, I can't remember that on the test.
2 Na goes to 2 Na plus goes to.
You do have to identify what's being oxidized and what's being reduced. Yeah.
But that's kind of pointless. It's just like saying 3 equals, or 0 equals -3 plus 3. Like
When we get into electrochem, we have to worry about how many electrons are moving around. So that's the way to look at it, yes.
So I know the test is multiple choice, but like, when does it want you to when does it want you to like put the solid in the
They'll have a multiple choice version thing. And you're trying to find out what the solid is. Okay?
And you find out the solid by the
NAGSAG. And then the PMS and Castrobear. Castrobear. So sulfates have exceptions. Sulfates have 2 exceptions. So NAG nitrates, A acetates, G group 1 metals. Those are soluble always. Then you get to the SAG, sulfates is the S. Sulfates have 2 exceptions. One of them is PMS, which is lead, mercury, and silver. And the second one is Castrobear, calcium, strontium, and barium. So when they're with those, those are solids. When they're not with those, then they're aqueous. With anything. With sulfates. So sulfates when they're with calcium, strontium, barium, or sulfates with lead, mercury, or silver are solids. But when sulfates are with anything else, it's AQ. Then you've got ammonia, always soluble. Then group 17 metals, which is fluorine's column, it is also not soluble when it's with PMS. So lead, mercury, and silver. So group 17 and the sulfates are not soluble with PMS, and the sulfates are also not soluble with Castrobear. Okay, so that's a good thing to go back over. Okay, that white sheet that I gave you last time, that is really, that packet, you really need to make sure you go over that, you understand it, because she's worded some things in there really weird. And so I tried to, oh my heaven. I tried, is it Friday yet? I tried to word it in the white sheet like she worded it so that you would get used to what she's trying to ask. Does that make sense? If you have a redox reaction, you know it's redox because you know an element by itself. If an element's by itself, you've got a redox reaction. That includes Braun-Hifkel. So if it's Cl2, it's still considered an element by itself.
And then would that be on the product and reactant side of each thing?
Doesn't matter, either side. If you have an element by itself, it's a redox. If you don't, it's probably not. Okay, so I'm going to give you time to work. I'll answer more questions as you need it. You're more than welcome to come up. You're more than welcome to come up and get help or yell at me and I'll try and come over to you. Okay? But try and go through that, at least that white part, because as we go through the, if you're coming tonight after school for the review for the test, that's what I'm going to be focusing on is the white and the salmon paper. Yes.
Night after school? Is that just right after school? Or
Yep.
Okay, I didn't know when you said tonight.
What time around that?
I didn't know if we were
What time is that going to end?
When everybody's done asking questions. When everybody's done asking questions, then I'll go home. Did you get that because it was the same answer?
Yeah. I heard you say something when I asked my question. I was like, wait a second.
Okay, we good? Okay, so you're working on either the white paper, the salmon paper, your homework, your lab, your Learn Smarts. Okay, get them done, get them in. Let's get them ready for the test. Yes?
What are we doing the 13th?
On the 13th, I think we have a lab. We've got a calories lab. A calories lab.
Can you explain the